good. Is everybody going to be gone on Friday? Just you, just two? Possibly three? That's okay. Anybody else? That's it? Okay. All right, so I'm trying to arrange this so it's the rest of the week so it's gonna work best with you guys. I may have lied to you today about being able to go through the tests today. What we may have to do, because I want to get started, I want to build in some time. Ideally, if at all possible, like I said, I'd like to build in a day on Friday when people could do retakes. And they wouldn't have to do it during advisory or something. So I'm trying to do that. In order to do that, I think if I got through enough material today, I could make that happen. But I think there's one more I need to. Hey, what's up?
Are you busy right now?
I am. I'm teaching right now. Do you need a letter? Is that what you're?
Yeah, but I wanted to make sure I tell you about it, not give it to you out of the blue or something like that.
Oh, okay. No, that's fine. Yeah. Are you gonna be around later?
Well, right now we're just watching a movie in pre-calc. So.
Okay. Could maybe swing by. How about next period? What do you have next period?
I have so I can swing by.
Yeah, do that. That should work. Give me about 15 minutes into the period, next period. Come by. Yep, you betcha. Okay, remind me at the end, Aubrey, I'm going to task you with something here. Remind me to pull people for who wants to be requested for advisory. Because if nothing else, we could go through test during advisory tomorrow. Okay. There you go. There you go. Okay, here we go. So we're going to look at today, we've got another technique for solving quadratic equations. So everybody click everything closed. Today's going to be a day where I'm going to teach you some, it's cool stuff, but you kind of got to be with me on all this to walk out today feeling like I feel really good about this. So think at the beginning of this unit, I told you that it culminates in us being able to solve any quadratic equation I throw at you. And part of that process is picking the right technique for doing that. Okay, so we've got two so far, right? We've got factoring, which when you can factor a trinomial, it's the quickest and easiest way to do it. For sure, if a is equal to 1, so it's a basic trinomial, you always want to just see if you can find magic numbers. And usually it's pretty easy to tell yes or no you can or can't. So that would be our first option. If it's a trinomial where a is not equal to 1, and we learned slip and slide, honestly, I mean, if it's really easy to do, yeah, maybe that's okay. But otherwise, probably don't bother. We'll probably move on to another technique that's easier. Okay, so I showed you how to factor because it's important to know how to do it, but we won't do it very much in practice when you're choosing the best strategy. Okay, the other one we talked about was if we're able to point to a single x in a quadratic equation, we can always isolate it with inverse operations, and that's pretty easy to do, right? That's another one that we like to be able to fall back on if possible. Okay, starting today, we're going to look at our last two techniques, and these are techniques that we would use if neither of the other ones work. Okay, so we're going to look at a process called completing the square today, and this is really pretty cool. It's a geometric kind of the way I'm going to explain it is using geometry. The way we're going to come up with sort of the formula for this is just using a geometric approach. But then once we've gone through that, we can distill it down to some steps you can go through. Okay, so first of all, take this picture, right? Let's just say that we've got a square of side length x, and then next to the square, we've got a rectangle that has the same, one dimension is the same. So it's going to be, in this case, the height is x, but the width of the rectangle is different. It's b. Okay? If I add up those two areas, I get the area of a larger rectangle. Agreed? If I put those two together. Okay? Well, our goal here is, and it's going to seem weird why we're doing this, but you'll see a connection here shortly. We want to see if we could turn this into something that is almost a square. We're going to be missing one little piece that we'll have to be able to add to what we end up with in order to complete the square. It's going to be an incomplete square initially, but eventually we'll get there. So what if I did this? Does everybody see that if I took this rectangular piece and if I split it down the middle, I could break it into two pieces, and each one of those would match up with the side of the square. Everybody get that? So what are the widths going to be? Well, if the width of the original rectangle was b, then each of those is going to have a width of 1/2 b and a length, or whatever you want to call it, of x. Okay? Give me thumbs on that. Everybody agree? Okay? So at this point, I've just got x squared plus bx, and when I reconfigure it, it looks like that, right? When I push those edges together, I end up with this piece that's almost a square. It's just got this little nick out of the bottom that I've got to fill in to complete the square. Okay, what are the dimensions of the almost square? Well, the height is going to be my original height x plus now I've added a 1/2 b to that, or a b over 2. And the width is also increased from x to x plus b over 2. Okay, everybody agree? But I've got to get this little piece in the corner that's going to fill in the gap and complete the square. Well, what would its dimensions be? Does it make sense here that the dimensions would have to be that height times that width? So it's going to be b over 2, or 1/2 b and 1/2 b. Everybody see that? So this dimension is b over 2, and that dimension is b over 2. And so the area would just be b over 2 quantity squared, right? That's the area of that little extra piece that I need to complete the square. Okay, why in the world would we do that? You're probably wondering. What good does that possibly do? Well, what this does is it allows us to take an expression like this. If I've got x squared plus some number times x, call it b, it allows us to figure out what's the number I would have to add to that binomial to create a trinomial that's a perfect square trinomial. Okay, what do we mean by a perfect square trinomial? If we back up a step to the things we were doing last week and the week before, perfect square trinomials, you tell me, see if you can tell me, let's practice with one regular trinomial. So how about this? If I have x squared plus 7x plus 12, what does that factor into? Everybody agree? X plus 3, x plus 4, those are my magic numbers. Multiply to 12, add to 7, right? Okay, how about this one? What are the magic numbers there? 4 and 4. Everybody agree? Aha, so that works out to be, when I factor this, it works out to be a square, right? This would be like, I could take, for example, I could take this whole area here. If I had a rectangle, or sorry, a square of width x, a rectangle that was 8 by x, and another square that was 4 by 4, and I could add all those together to create one x plus 4 by x plus 4 per square, right? This is a perfect square. I don't have to complete anything. So this is what we call, because it factors into the same magic number twice, so I'm getting a factor squared, this is what we call a perfect square trinomial. Okay? And so what we're looking at today then is, given x squared plus bx, what could I add to that to create a perfect square trinomial? And the answer is, well, we just figured it out. I have to add this little piece down here at the bottom. Whoops. I have to add this little piece, b over 2 quantity squared. And then I create a perfect square trinomial. Okay? What do I create? Well, if I rewrite that, that's the same thing as x squared plus bx plus b squared over 4. And I guarantee you that factors into x plus b over 2 times x plus b over 2. Every time it's going to work. Okay? So we just figured out that if I start with these two terms, that's the term that I add to it to complete the square. Okay? Here's why. Well, we'll start to look at some applications of why is this so useful. Here's just a summary, I guess, of what we did for your notes. Okay, so why is this useful? Well, if I wanted to work backwards on a problem, okay, let's take this guy. I'm just going to create a situation for you where you can see this. Okay, so what if I wanted to solve this quadratic equation? How would you solve that based on everything we know before today? What would you do to solve that quadratic equation?
Would you set the other side to 0?
Yeah, everybody agree? I've got to put it in standard form, right? Everybody gets that, right? Give me thumbs on that, on how confident you are with that step. Everybody get that? Okay, yeah, we got to set it equal to 0 so we can apply the zero product property, right? That's what we would have always done, and that's what we should do, right? In general, that's what we should do to solve a quadratic equation. I've got to put it in standard form. So x squared plus 8x. If I subtract 64 from both sides, I'm going to get minus 48 equals 0. Okay? Then what would I do? What do I have to do to the left side? You got to factor it, yeah, right? You got to factor it so I can apply the zero product property. So what would my magic numbers be that multiply to negative 48 and add to 8? I'll let you think about that for a second. Multiply to negative 48 and add to positive 8. There you go, 12 and negative 4. Okay, so we get x plus 12, x minus 4. So I get my solutions, x equals negative 12, or x equals positive 4, right? That works. And we could plug them in, and they would work. They check. All right, so now let's see if we can come up with a different way of doing this. Let me copy. Let's see. I want to do this. I'm going to take all that stuff right there. And let's try doing this maybe a slicker way. Now, we already can see in the blue box up there that kind of pieces got cut off of the blue box. But in the blue box, we already had this relationship. We knew that x squared plus 8x plus 16 just happens to be a perfect square trinomial, right? So what happens in this equation down here if we replace this perfect square trinomial with the perfect square that it factors into, right? Look what happens. So this is the same thing. This trinomial is the same thing as x plus 4 quantity squared. Now that looks like a much easier equation to solve, doesn't it? That's the kind of equation where I can point to a single x, right? So what would the steps be to isolate x there? Say it again, what do I do first? Square root, there you go, good. So if I square root both sides, I get x plus 4 equals plus or minus what? 8. Well, that's pretty quick, isn't it? Last step, add negative 4 to both sides or subtract 4. I got my answers pretty quickly. X equals negative 4 plus 8, which is 4, or x equals negative 4 minus 8, which is negative 12. Okay, so can you see potential for an advantage here? What this could do for us, this completing the square thing, it could allow us to always take the first two parts of a trinomial. Where is this stuff? Right. Lost myself. Oh, right here. I could always take the terms x squared plus bx and add, like if this is an equation, and add just the right number to both sides of the equation so that on one side I'm going to create this perfect square trinomial, so I can do something like that, right? I can without having to factor this thing, I can create an equation where I can isolate x instead of having to factor. So you see there's potential for a big advantage for this as an algebra technique for us. Okay? All right, so where do we go with this then? Okay, so let's practice this process just a little bit. There's a very simple step for figuring out, it's just a matter of kind of going through this simple algorithm to figure out what the number is I have to add to create a perfect square trinomial. And all it is this. I'm going to take half of b, where b is the coefficient of x. Oh, and by the way, something that needs to happen in order for this to work, the trinomial has to be in the form x squared. A has to be 1. X squared plus bx, right? And then I'm going to take half of b and square that and add it to both sides, and I've got it. I've created my perfect square trinomial. So let's just say this is one side of the equation. There's some other stuff on the other side that we don't really care about for now. But I want to create a perfect square trinomial on the right side of this equal sign. Okay, well, what's the number I would have to add to both sides? What's b in this case? What is it again? Negative 1/5. We got to get the sign in there too. Okay, so b is equal to negative 1/5. So then b over 2 is equal to what? Same thing as 1/2 times b. That's the same thing as negative 1/5 times 1/2. So what is it again? I think I heard it. Negative 1/10. Okay. So there's b, and what we really want out of this is half of b squared, right? So what we really want is to take that number and square it. So what's that going to equal? What's negative 1/10 quantity squared? What's negative 1/10 squared? Yeah, everybody get that? When I square a fraction, don't I just square the top and square the bottom, right? So there it is, right? There's the number I need to add to create a perfect square trinomial. Well, there's the trinomial I would get. I would just add 1/100th to my first two terms, and then how's it going to factor? Yikes, do we have to think about magic numbers to factor this thing? No, you don't. Every time it's going to factor into, this is going to factor into x plus b over 2 quantity squared every time, right? So for us, what was b? B over 2. B over 2 was negative 1/10, right? So whatever b was, I combine that with x, and that is my perfect square. Okay, that's the factor that's going to get squared, right? So that becomes x plus negative 1/10 squared. Well, I would just write as x minus 1/10 squared. Anybody see that? Okay, let's practice one of those. Do you want to go to the board? Do you want to do it on paper or the board? I don't care. Raise your hand if you want to do board work. Okay, go to a board if you want to. That's fine. Go to a board if you'd like. You can do it on paper if you want to. I'm just going to make one up for you here. So I want you to do two things for me here. Okay, so yep. Should be a bunch in that black bin over there. I think there should be a whole bunch of them. So I'd like you to do these three things then. Oh, man. Fill in all those blanks. I want to know if I start you off with these two terms of a trinomial, what's the number I have to add to create a perfect square trinomial? So then just write down the perfect square trinomial here. And then I want you to write it in factored form. Okay? So when all is said and done, you're going to have x plus or minus some number squared. Yeah. Yep. So you'd write it that way right there. Yep. And the second box, all I really wanted was just x squared minus 22x plus 121. See what I'm saying? Yeah.
Why do you guys ask me?
There you go. Good. Yeah, that's it. Yep, you got it. Good. There you go. Okay. That's good. It's hard. I didn't really explain what I wanted all that well. Yeah, that's it. Yep. Okay. What do you got there, Jack? Let's see. Okay. Hey, let's zip through this one real quick as a group. So here's what we'd say. So what's b in the first equation? Negative 22. So what's b over 2? Negative 11. Okay, so the number that's going to go here is negative 11 squared, right? Half of b squared. I kind of like to write it this way, believe it or not, and you'll see why. Because then when I write out the perfect square trinomial, I just get x squared minus 22x plus 121. But when I write out the factored version of that, whatever the number is that I'm squaring, so in this case it's that negative 11, that's the number that goes in there, right? Whatever b over 2 is, ultimately that's the number that's going to end up in my perfect square, my factored version of my perfect square trinomial, okay? Let's do one more, just real quick, one more for practice. So I want to know, okay? Okay, there you go. So I want to write out what the perfect square trinomial is going to be and what its factored form is going to be. Okay, good. That's a good first step, okay? Yeah, that's good, 121 fourths, good. So now, what's it going to be, like what quantity squared? So we want to write it in factored form as a perfect square. Okay. Okay, so it's this part squared, right? And that part squared is just going to be, oh, that is, yeah, you don't want it as we want it as a fraction. So it would be 121 over 4. Yeah, you're right. I mean, those are, as decimals, those are right answers. We just want them as fractions. Yeah, yeah. Okay. Yeah, that's right. You just wrote them as decimals also. Okay, good. So then what's going to go there? The x plus blank. It's whatever was being squared. But the number that you squared to get that, which is what? 11 halves. Yeah. Yep. Okay, so to me, you're starting to see maybe a little trick here. If I see a problem like this, I do it backwards. Because I know the number that's going to go there is going to be 11 halves squared, right? So I already know down here that the factored form is going to be x plus half of that squared, right? That one's the final answer is easy. It's just x plus whatever half of b is, quantity squared. The perfect square trinomial is a tiny bit harder because I actually have to square that number out, right? What I've really got in here is positive 11 halves squared, which gives me x squared plus 11x plus 121 fourths. 11 squared over 2 squared. Okay? Make sense? Looks like you guys are getting this. Okay? Okay? One more? Okay? All right. Okay, so I want you, I'll tell you what I want to, rather than do these kind of contrived problems, let's just inch forward a tiny bit and I can give you like a kind of a more, like a problem that makes more sense to think about, like an equation with this technique in there. So grab a seat real quick and we'll just look at a couple very quick examples. Like this one right here, okay? So we're going to solve this by completing the square, okay? All right, so how we could potentially solve this by factoring, maybe, but maybe not if we couldn't find magic numbers. And I'm not sure we could. I don't think we can. I don't think this one's going to work. I don't think there's going to be magic numbers to factor this. So how would we solve this by completing the square? Okay, we're going to start off by setting ourselves up to create a perfect square trinomial on one side of the equation. Well, these are the two terms. Whoops. these are the two pieces that we need to create a perfect square trinomial, right? We're going to pick just the perfect number that fits with those two pieces. Agreed? This 56 probably doesn't fit. So we're just going to get rid of that. We're going to essentially just store that on the other side of the equation. So we're going to chase this one out of there to the other side. So we get equals, and then on the other side, we've just got this negative 56, right? So now on the left side, we want to complete the square, keeping in mind that it's an equation. So whatever we add to the left side, we must also add to the right side. So what would be then, we've got to add this missing number to both sides, because it's an equation. And we want to add that number so that the left side is going to factor into a perfect square trinomial. Okay? So the whole point here is that on the left side, I'm going to be able to break this thing up into, well, I don't want to write it that way. I want to be able to break this thing up, factor it into that whole thing into something squared. Okay? And then on the other side, what am I going to get? Just some number. And I can solve this thing by isolation then, right? Okay, you see the template that we're building. Okay, well, what is the number that I'm going to have to add to both sides here? What's going to have to go in that red box? 81. How'd you get that? Half of negative 18 squared. Okay, so I'm going to write it this way. I'm going to write it as negative 9 squared, okay, on that side. And over here, I might as well just write it as 81. I've done the same. They mean the same thing, don't they? But I'm going to write it this way because then I know that down here I'm getting x, whatever number is being squared, is what couples with x to create my perfect square, right? On the other side, what do I get? Well, negative 56 plus 81 is 25, right? And now we're done completing the square, and I've got a really simple quadratic equation to solve. Everybody get that? Okay. So then I would just square root both sides and get x minus 9 equals plus or minus 5. So x equals 9 plus or minus 5. Done. Okay? So then that's giving me 14 or 4, right? Okay? Again, what was my strategy? I had to get rid of this term, push it over to the other side so I could make room to create a perfect square trinomial on the left side. Yep?
Could you also just separate the 56?
You could, yeah. So the other thing I could do with this, and it's a good point, and some textbooks will even teach it this way, is you could just do we could do this. And if you really want to do it this way, I guess I'm fine with it. But it's almost better if we just all do this kind of the same technique. Oops. Okay, what Carson's saying, it's a good idea, is could we just rewrite this as x squared minus 18x plus 56 equals 0, right? And then you could say, okay, well, what do I have to add to this? We already figured out that I'm adding negative 9 squared, which is 81, right? So I'd turn right around and subtract 81. So this whole, why do I have to do that? Well, then the whole thing just equals 0, right? I add and subtract the same number. And then I would take these three pieces right here, and they're going to become x minus 9 squared. I could combine those two and get minus 25 equals 0 and just solve it the way we did before, right? So you could do that. I don't know. To me, this way just seems easier. Seems easier, and I think it's a good strategy. I guess I gravitate to this because I've done so much math way beyond what we're doing now, and a lot of times you do stuff similar to this. And so it's kind of a good habit, sort of a good bookkeeping habit to just store stuff on the utilitarian side of the equation. This is the action side. This is where we're trying to do stuff. The other sides, we're just storing a bunch of garbage, that eventually we might want to retrieve it. But I just want a clean side of the equation to do the completing the square process. So I really do kind of almost philosophically like this way better. Okay? All right, let's try another one of those. Okay, before we jump into this one, I'm going to make one up for you. Just get a little practice. Go to the boards. Let's try this one. Okay, try that one. Don't forget the x, Ashley, by 10. Okay, and now, and just a hint, everybody looks like they're doing the first step correctly, but just a little practical hint here. When I push this 14 to the other side, put the equal sign clear over there. Leave room to add that number. You see what I'm saying? To fill in that blank. Okay, now you're adding to both. There you go. Perfect. Yeah. You see why? Okay. There you go. You want plus that quantity though, right? There you go. Good. See if you can make that plus sign a little smaller. Oh, I'm out of time. We'll pick it up tomorrow. Yeah. Yeah, so you added 25 to negative 11 and you got 14 on that side, right?
Yeah, wait. I added 25.
Oh, no, you're right. So, okay, I see what you did. No, you're right. You got 11. Yep, you're right. Yep, you're right. Mm-hmm. Equals 11, and then you'll just isolate the x, and you got it. Yep, good.